Welcome, everybody. Thank you for being here. I think you're going to find this to be a particularly valuable community meeting with Beyond Efficiency and the things that they are doing. I wanted to go to first. Thank you to Beyond Efficiency for prepping with this and doing it. And then we also want to say thank you to our sponsors. We're Passive House California. And if you'd like to join, you can go to passivehousecal.org and you can get a membership. You can sign up for the newsletter, things like that. We are a part of the Passive House Network, and we are connected with the Passive House Institute and the International Passive House. So, it's we're strong for that level of what's there. Want to thank our gold sponsor of Southern California Edison. We appreciate that. Our silver sponsors are Small Planet Supply and Earthbound Homes, which is he's a builder that builds residential in the Bay Area here, and I think he's got 11 passive houses in planning and underway. It's really shifted to have almost all of them there, I believe. And then we have supporting sponsors, 475 Building Products, Rockwool, Fergus Garber and Associates is an architect in the Bay Area, Ream and what was I look? Well, I'll find it when I get there. And Stiebel Eltron are there are two that do heat pump water heaters and heat pumps associated with that. Pete Moffett is a construction company. Hayward Lumber, they have lumber yards up and down, and Bill Hayward is on the board of Regenerative California. This is Cyril's company is CPHBA, so we appreciate them. Good Space is another builder contractor that's in the Sacramento area up there. Intelligent Membranes and Prosoco are both membranes and liquids and things that you use to air seal and allow moisture through or allow they're permeable. And then Icon Windows and Doors are that's a New Jersey company, and we have a lot of Icon windows up in California, thanks to Christian and some others. And finally is Todd Jersey Architecture, that's in Berkeley, right, very close to the Beyond Efficiency's initial office, and they're a sponsor as well. So I'll go back to the thanks to Beyond Efficiency, and I will now unshare and turn it to Katy to share.
Yeah, well, it's so great to be back with the Passive House California group. I used to be really heavily involved and was one of the kind of co-founders of this, along with I saw Graham Irwin's name here and a bunch of other Bay Area people. But yeah, really awesome to be back. I'm just super busy these days, so I don't get to spend as much time with groups like this as I'd like. So I think for anyone that kind of came later, I'm co-presenting with my colleague Nathan or Nate Russell. So I'm going to be kind of jumping in primarily for the first half, and he'll take over the second half. And we definitely invite you to, jump in with questions as we go, rather than kind of just a solid presentation with Q&A. So feel free to jump in, and a couple people will be monitoring the chat. So, that would be the best place. Just put any ongoing questions or things you want clarified in the chat. Okay, so let me jump in here.
And by the way, we're over 60 attendees so far.
Wow, that is amazing. Okay, and now somehow, even though I was all ready to go before, I'm not seeing my PowerPoint presentation anymore. So let me try again. All right. Okay, and you're seeing the wrong. Okay, everyone's seeing fire resilient undeveloped HVAC design without all the notes?
No,
Okay.
we see the notes. You have to swap your.
Oh, you do? Okay, I have to swap it again. That happened before. All right. Now?
We still see them, but it's beautiful.
Huh. Okay, let's try once more. This was working when we just tried it out. Still seeing everything?
Yes.
Okay. All right. Sorry.
Oh, yeah. Have you gone to if you've gone to slideshow, it should show on the whole screen.
One more time here. I know, we really did just go through this and it worked at the time. Let me just try again.
I
Still
open,
not, huh?
I open my screen. So if it's not working, I can share it for you if you want.
Okay, shoot, hold on. It's still not, whenever I swap displays, it like swaps something.
Can you say use slideshow at the top?
Okay, that's fine. I don't really, oh, now it all went
oops.
away. Oh boy, what is going on here?
Cyril, do you want to go ahead and share?
Yeah, why not?
Okay, sure, we'll let you do that. Sorry, everybody. We literally just went through this, but it's not working now. And I had stuck another slide in there after, but it's okay. We can just sort of talk about that or jump to it after. It's something on open kind of diffusion, open vents.
Mm.
Have you got two screens, Katie?
Yes, I do.
You might want to move your move the PowerPoint to the other screen and make sure you're sharing that because it's got your main screen on the speakers deal where you have the next bingo.
All right, we'll just do this. Okay. All right, let's jump in. I know time is ticking away here. So let's move on. Oh, well, actually, yeah, before this, so this was a actually you can go back. So I'm sure a lot of you know Jackie Lowe with Boone Lowe Ratliff Architects in Santa Cruz. So this was a house she designed, a fire rebuild up in the Santa Cruz Mountains, and it's just our main role on this was around the mechanical design, but you know we did kind of gently advise on some envelope practices, and they had someone with it's some like South Bay University that came to visit it, and they said this was like one of the best kind of fire resilient designs they'd seen, and they felt like it you know they implemented a lot of things properly. So some of these we'll be getting into today, but you know one thing you can see just as an example is it's not overly glazed on the wildfire, you know, the main kind of hill where the original wildfire came through back in, I guess it was this 2020. And that's one of many features that is going to make a home more resilient or any building more resilient, actually making the wind openings a bit smaller. Okay, we can go on. So Greg Chasen is on the call. So he was the architect of this home. This was like kind of the, you know, picture that went viral of like entire neighborhoods gone. And there was like the one building left standing. So this was not a certified passive house, but Greg has incorporated passive principles in his projects for 10 or even 15 years now, Greg, I think, from the first time we had worked with you back in like 2011 or 12. And you know what, we did not work on this, so I don't know exactly all the details, but some of the things you can see here are, you know, minimal overhangs, which I don't otherwise necessarily like from the standpoint of like solar gain management and bulk rainwater management, but it definitely is a best feature in wildfire areas. High attention to airtightness, detailing, minimal openings, a lot of other things like that. So the hope is that rather than this being an exception, it really is the norm. So rather than 1 out of 100 homes left standing, right, it's 99 out of 100 because of applying, yeah, just sort of some basic resilience strategies. So before everyone else joined, Jay had mentioned that he just saw a statistic that in these recent fires, 90% of them were shown to be actually instigated with embers. And that's a really key thing that will be a thread throughout today, that embers actually are responsible for, it's estimated to be 90% of fires. So it really is a big deal. So we want to focus on openings. We want to think of areas where embers can collect, and if there's combustible area, if there are combustible materials in that area that could again ignite, and then obviously ignite other combustible materials that are adjacent. So obviously direct flame contact is also important. Radiant heat is another pretty big one, and that's where some thought around how windows are designed and detailed can go a long way. So we're going to dig into examples of all of these. Sorry, you might have to go through some of these have animations. And is it Cyril who's advancing?
Yes, yes. I'm
Okay,
trying
thanks, Cyril.
to-
Yeah, so if you don't mind, yeah, really sorry about the issue
No,
here.
it's yeah, tell me.
But,
I'm gonna press the button.
yeah, but anyway, but something we like to think about, rather we're trying to like, reduce energy loss or save water, is like, how do we get to the root of the problem to start with? So obviously, number one, when we think of wildfire risk, we want to minimize risk from the outset. So that's where defensible space comes in. We're not going to talk about defensible space today. We're really focused on the building itself, and it's just, otherwise not really our own area of expertise. These aspects of ember and flame smart design strategies. And then when possible, to just eliminate any small openings that where possible, otherwise, reduce the numbers. And then where there are openings to protect them, we'll be getting into details on that. Tempered windows. I think there's been there's a lot more awareness and focus on the specification of windows with these recent fires, especially. And this is just, this is a great little graphic from the Insurance Institute for Business and Home Safety that just highlights, some of these things. So then if fire does start, how do we again minimize its spread? So like step two would be, number one, we want fire not to start in the first place, but if it does, we want to have non-combustible materials, have things like properly placed dampers in HVAC system ductwork to minimize fire from spreading or minimize embers from getting deeper into the system. And then the final step, if you advance against Cyril, is to put the fire out, obviously. But again, we're focused on 1 and 2 today.
Really quick, will these be available? There's a question whether or not the code slide will be, the slideshow will be available.
Yes, absolutely. And I think you also record this and post it. Is that right? Yep. So yeah, the slides will be available as well as the recording. Okay, so but a good mindset to have is to kind of think like an ember, and where are embers attracted? Where are they going to end up? So this was a great tip. I think it was from that Insurance Institute organization I just mentioned, of like paying attention to where leaves and higher elevations or in areas like Tahoe, where do snowdrifts occur? And this, you can look at this both, at the surrounding of a site as well as on the roof. So on some roof areas, you might see, just because of, how the wind blows, there are never leaves or never snowdrifts. Whereas on the other part of a roof, there could be like 3 feet of snow sitting in some corner. So this is a good way to start to get an idea of where embers might land and where to pay extra attention to, if possible, to design so those areas are minimized or eliminated, or at minimum, again, just don't have combustible materials on those locations, or make sure that these areas are protected from being able to combust something if an ember does get stuck in an area. And then another general tip is to actually design seeper roofs, where if embers land on a roof, they're more likely to roll off. I can't tell you what the sweet spot is, but as a general rule, all things being equal, a steeper roof is going to reduce embers from sitting in one spot. And then another thing is fire smart. So if active flames do start in an area, where are they going to tend to kind of get stuck and grow from there? So I think this is what a lot of us are most aware of when we think of fire smart design of areas of soffits, of balconies. So just again, being aware of where those are, and all things being equal, again, if you can just eliminate the problem from the outset by not having those things, that is great. But we're also designing for people and for functionality. So that's really not going to be possible to completely eliminate these risks. So minimizing them when reasonable. And then finally, with whatever is left, just considering, okay, if flames do end up in an area, how can we prevent that from spreading? This is a little graphic from Fire Safe Marin showing a minimal eave. And, this is an area where I personally feel a little conflicted. I like deep, or at least, decent overhangs, again, for the purposes of keeping water off of walls, and just to be part of the solar control strategy. But it's just one of those many things, right? There's you optimize for one thing and it might be kind of at the detriment of another. And so just all things being equal, understanding that overhangs are a risk and to keep that in mind when designing. So small openings are a huge a major contributor to embers getting into literally inside the envelope of a house and starting a fire in the attic or in some sort of space. And Jay, you mentioned you had another statistic that when we were chatting before, that of all the the fires that were ignited by embers, that what percent of that was from like getting trapped in an interior place? Did you say that was 80 or 90%?
They said that 90% of the fires of the residential buildings that caught fire by embers, and again, it was the firemen discussing it that as they looked up and down the streets, the houses were catching fire from the inside more of the time than they were from the outside. And a way to understand that is the wind was blowing 70 to 100 miles an hour in this storm. And in the same way that when an air blows over an aircraft wing, the molecules have to get further apart to go around the wing, and it lifts the wing up. What happens when they blow around a building or over a building is they depressurize it, and it really sucks the air out of the building. It will break windows sometimes even. But what that does is embers blown in a 70-mile-an-hour wind don't land on your roof very often. But if the upside, if the house is breathing, is going breathing back in because all of the air has been pulled out as the wind goes over it, those embers get sucked in the attic vents, the crawl space vents, cracks under the windows or broken windows, under the door, catch the drapes or catch the the rug on fire, that sort of thing. And the firemen noticed it as they were watching that a high percentage of the homes caught fire from the inside. Because once again, no matter how many embers are in the air, when they're coming at you at 70 miles an hour and bouncing across the house, they don't necessarily catch the outside on fire as often.
Yeah, they're getting sucked in. Yep. Thanks. That
Thanks,
was,
Brad.
yeah, really fascinating. So, again, kind of back to that logic. Number one, where can we eliminate openings? So unvented roofs, unvented crawl spaces are really basic, great best practice. We do a lot of cold climate work. I really like having vented roofs in cold climates to minimize ice damming. When you've got like 3 feet of snow on a roof, the bottom layer will actually generally be above freezing. And so that snow can melt and cause ice dams. But so there definitely are ways to design fire safe vented roofs. But for most of the projects, I'm guessing most of you here today are working on, you probably don't have that design goal of building a cold roof to minimize ice dams. So there are various methods of doing unvented roofs, and you just eliminate the problem, right? No soffit vents, no eave vents, and it also, in a lot of cases, contributes to having a warm attic, which we love as mechanical designers, to have your ductwork and equipment in a warm space. And then similarly when it comes to crawl spaces, fire safety aside, just from moisture risk and for thermal performance, having sealed, insulated conditioned crawl spaces are just really kind of a basic best practice now. So, and we'll get into a little more details on some of these things. But yeah, those are great. And then in terms of reducing openings, and Nate's going to be getting into mechanical stuff a little more after I'm done. But and being a passive house group, everyone here is likely on board with having heat or energy recovery ventilation. It's really optimal for air quality, and even when you might not be able to justify the benefit of that recycling energy, if you're in, say, San Diego, just having a balanced system where you're balancing supply and exhaust, and you're not kind of inducing exfiltration or infiltration from your mechanical system is definitely a smart strategy for fire resilience as well. So and the nice thing about HRV or ERV, if you're able to tie, all of the bathrooms into it and not have separate exhaust fans, is you're just, every place you can eliminate an opening is a another bonus when it comes to fire resiliency. And then, you know, where you do have openings, just ensuring everything is, you know, WURI rated. There is, you know, but that doesn't cover mechanical openings. And so we will be getting more into that later as well. So this isn't focused just on fire resilience, but it is a graphic we had put together that highlights some important aspects of the envelope and mechanical systems that do happen to, you know, play well, you know, relate nicely to fire resilience. And if you could advance again, I'm just highlighting on here this item in the top for source control. If you could advance, Cyril. Oh, actually, sorry, that was on my other one. I think I added it later. Or yeah, what happens if you do advance? If you press the arrow, okay, thank you. Oh, yeah, just go back again. So, but yeah, you know, number one, just from an air quality standpoint, as well as resilience and kind of minimizing these, yeah, just minimizing fire risk. You know, an airtight or reasonably airtight, when it comes to passive house, we would say very airtight, but you know, whatever makes sense for the project, right? Reasonably airtight is a really important step when it comes to fire safety. Because if you can minimize, you know, air getting sucked into, getting sucked through an assembly, it is a great fire resiliency feature. So now we can go on again. And we're not going to focus a lot on airtightness today, but from a kind of best bang for the buck approach that also is aligned with typical construction practices, that isn't necessarily a European approach of putting sheathing on the inside. You know, that can be a great solution, but it's not something we tend to do on our projects just because it does kind of complicate structural design and some other things. So there's just so much benefit in designating that exterior structural sheathing as a primary airtight layer. And then if you do self-adhered products, not only do you get a great weather-resistant barrier, but also a really good starting point for a comprehensive airtightness strategy across the whole building. And you know, there's a lot obviously that goes into airtightness detailing. You know, the weak points we typically see are sill plates on top at the foundation wall. If there are overhangs that are created from roof rafters that like penetrate exterior blocking, those are just need thought to be properly sealed. And we're not going to get into details on that on the interest of time. But yeah, you know, basic passive house practice of a lot of attention to airtightness really is an important strategy for airtightness or for fire resiliency. So we can keep going here. Okay, so yeah, sealed and conditioned crawl space. So, you know, essentially, depending on the climate and how the above grade walls are tied into the foundation, you know, generally what is appropriate for kind of coastal California is insulating the crawl space walls inside or outside, different ways to do it. And then either, you know, the entire floor of the crawl space or at least coming in some amount, again, depends on the climate and other things. But the main point here is don't vent the crawl space, right? We want to eliminate all those exterior vents. This solution just does so much better than, you know, the decades we spent venting crawl spaces. And this is the case for almost everywhere in the country. And yeah, you can keep going. Want to insulate walls, seal the entire, you know, all the surfaces with a vapor barrier. And then the conditioned part means this does have to be considered conditioned space and exchange air with the main house. So there are different ways to do this. What we generally do if we're you know, doing an HRV or ERV in the main house is just have one exhaust duct serve the crawl space, and then it will just need sort of a passive relief grill that could be like on the floor of a pantry or something like that, so that you are getting that air exchange. And again, not much is needed, only 1 CFM per every 50 square feet. So there's a lot, we could spend a whole, 2 hours on roofs, but we'll kind of try to keep it high level. Again, all things being equal in where fire resiliency is a primary goal. Venting, or sorry, not, doing an unvented roof is definitely going to be the best practice. But that can get tricky then with, well, how you do an unvented roof and not have, condensation issues. So we're going to just on the next slide highlight, kind of remind everyone of the different methods for designing moisture safe roof assemblies. So the first one is to keep the sheathing warm enough so that moisture that does migrate through the roof assembly can't condense, or at least can't be at those condensing conditions long enough to cause issues. So that's where above deck insulation comes in. But I think, for a lot of you here, it's another expense and step. We usually already have so much R value in the roof. There isn't really necessarily a huge benefit from getting another R5 or R10 above, in terms of just the contribution of the roof to the, heat loss in a home. So, and it just does add complexity. So there are other ways to provide a moisture safe roof that's unvented and will, is a good match in these WUI zones. So, then this other one in item B is to, if you're only insulating the cavity itself, have either airtight or vapor closed insulation for that layer directly adjacent to the roof deck. But unless you want to cut and cobble, a rigid product in and seal the perimeters, which is not very constructible, you're really looking at a spray foam on the bottom. And we really advise and discourage spray foam when you can design around it. So we're not really a fan of, of option B there in most cases. So then you can carry moisture away by ventilating under the roof deck. But we're trying to, again, not vent, right? So we can eliminate those openings. So that means the other option here is D, allow moisture to diffuse out with these diffusion open ports near the ridge. And I did kind of sneak in a slide, but it's actually not in this, in what we have open right now, on what that diffusion open detail looks like. So if we have time at the end, I can open that up and we can look at it, or we'll just be sure that it's in the final slides that we share. But yeah, this is just a comparison of kind of conceptual comparison of different roof approaches, and certainly just doing continuous rigid on the outside is a really great solution. But there are obviously cost and labor impacts. So that middle one is the vapor diffusion port. So the concept is basically that you do, let's just say you're doing a dense pack roof, dense pack insulated roof, and without exterior insulation, which presume, and until recently wouldn't meet code, but you actually allow diffusion or allow vapor that is collecting in that roof assembly, which will always be collecting in most situations up near the ridge, to evaporate out through this diffusion open port. So it's similar to doing a vented roof ridge. If you're doing a vented, a vented roof with ridge detailing, similar sort of detailing, but you're just allowing the vapor to diffuse out. So again, I'll try to we'll open a couple concepts of that later. This is only appropriate in mild climates, and you also have to have steep enough roofs. And if you have a complex roof, it's really not going to be a good fit. But there are a lot of I think there's a lot to like about this vapor diffusion port detail for cost reasons, as well as, again, the benefits from fire safety.
Excuse me, are there any concerns about smoke penetrating the enclosure once the interior is depressurized, as was spoken about earlier?
I'm not totally following you. Nate, did you understand Martin's question?
I mean, is that in relation to the 70 to 100 mile per hour winds?
Right, so can
With
smoke
embers being forced?
is basically it with this diffusion port.
With the diffusion port, no, that's not really connected. It doesn't have a direct connection to the exterior. It is totally inside the building envelope. So that the vapor diffusion port itself is not going to be a direct entrance point for embers or smoke or anything
Okay.
like that.
And yeah,
Okay.
I'm sorry I don't have the graphic here because it would be much easier to describe this. But basically, there isn't there's like a vapor open membrane
Uh-huh.
that is incorporated into the ridge detail. And so you actually hold the roof diaphragm back a bit, which is, from a structural standpoint, it is very doable. But the structural engineer will need to be part of the detailing for that. So yeah, if we have time, we'll definitely open that, open that
Okay.
detail. I think
Right.
it'll make a lot more sense when we have the visual.
Thank you.
Yeah, thanks, Martin. Okay, we can go on, Cyril. And I think we need to, Nate is gonna take it over from here.
Sure. So, so if we go a step further, looking at the walls and protecting them from the embers and just using non-combustible materials. I'm showing an example here with fiber cement, but it can really be any non-combustible metal, stucco, thin brick, stone, thin brick or stone veneer. And what we're doing is we're showing a drainable, a rain screen here with furring strips with the cladding running over furring strips. And to protect this from the embers, it more or less requires sealing the top ventilation area, the ventilation gap at the top between the freeze board and the top course of your cladding. It allows the air to come out there, but just sealing that, or not sealing that gap, but installing your 1/8 inch fireproof mesh at the top there, allowing it to vent out, but not allowing the embers to enter. And then in the bottom right, when we look at the bottom, it's just adding in that 1/8 inch metal screen in between the furring strip gaps, and that'll prevent embers from entering from the bottom. And then with the screen at the top, there's really no path for those embers to enter. And then with your furring strips close to grade, as well as your exterior sheathing, that should be a fire rated product as well.
I just want to make sure that we are all able to see the walls slide here. Do you all see that? Anyone not see Cyril's slide? Okay, sorry.
Hi, everyone. That's me. I think I've got the wrong view thing on, so I'll figure it out. Hi, everyone.
Hey.
Sometimes at the top of your window, there's a little like tab at the top of Zoom, and you can click which display it's showing.
Yeah, if you mouse over, you should see Cyril Pettit's screen. Got it? Right. Thanks, Cyril. We can move on to the next one now.
I had a quick question.
Sure.
How important do you think it is to vent wall cavities versus have a drainage plane, like maybe open at the bottom but not the top? Like, how much venting is really going on in there on a regular basis, and is that worth the liability? I'm sure in a wildfire with 70-mile-an-hour winds, it will draw air through there, but like on a day-to-day basis, is it really doing enough to justify that risk?
I mean, I think it's the most robust approach. It improves the durability of the siding by back venting it, and there are some issues. If, for example, you can just perhaps vent the bottom and not open the top, but there are concerns with moisture accumulating up at that high level and paint peeling in your top 2 or 3 courses of cladding in this case. An alternative approach too is if the exterior rigid is only say 1 inch to 1.5 inches thick, you can sometimes apply your siding directly over the rigid insulation and avoid the rain screen detail completely. And with mineral wool, that's using mineral wool as the exterior insulation. That's kind of a drainable exterior rigid insulation. So there's some durability there, but there's also the trade-off of maintaining planarity with the cladding, especially over mineral wool, since it's more compressible than the other materials. So it's a trade-off, and I would say in the drier climates it's probably a lower risk, but in wetter, I would be hesitant to remove the drainage plane there. And again, when we're looking at this assembly, this detail too, using all non-combustible exterior components, there's nowhere for the embers to go. So if they go up there, there's nothing to burn, provided that it is well sealed.
Yep, exactly. And that would be a point in the column of, mineral wool as opposed to, say, EPS insulation. Because if there was an ember sitting on the bottom of kind of that metal screen, right, and it does get to the point where EPS could burn. So, it's hard to like argue about mineral wool, but I'd be personally really interested to hear like studies that have been done with ember ignition of cork. Cork, I'm sure a lot of you have seen studies on it. You can get it to like ignite, but then it'll self-extinguish. So I do, intuitively, I do feel like probably cork or some of these other really dense materials would probably also be safe in the system. But, it's hard to do this, to do a mineral wool insulation without having furring over because of the reasons Nate said of, it's just so squishy, even the most rigid stuff. But if you did want to really eliminate that gap, then doing a different type of insulation with maybe just a drainable product. If you depending on how the whole assembly is designed and how you're draining, on top of the sheathing. But there are definitely ways, right, of doing cladding right on the insulation without that gap. But it's probably not going to be mineral wool.
If I had a question about the same thing, Katie. If you have two different materials, say mineral wool if you put all mineral wool, it's extremely expensive and prohibitively expensive to put in about 3-4 inches of mineral wool for affordable housing. But if you put the exterior layer of mineral wool against the air gap, the evaporation channel, and then put something like cork or EPS on the inside, is EPS acceptable on the inside of, maybe put 3 inches of EPS and then 1 inch of mineral wool? Does that work? So your EPS is on against the sheathing and your mineral wool is against the air channel.
Want to take that, Nate?
Yeah, sure. I mean, I'd be inclined to say it would work because it's just embers finding their way. In general, it should just be embers finding their way up there, and an inch or so of mineral wool should protect the EPS from the direct contact from the ember itself. And then with the fiber cement siding on the exterior and that air gap, that's along with the mineral wool, that's protecting the EPS against the radiant energy coming off of the flames itself. So that combustion path, that risk seems like it would be much lower as well. So I would be inclined to say that would be acceptable.
There's another addition one might make, is to put the bottom 1 or 2 feet of insulation, all mineral wool, and then the section between the bottom and the top, put in some EPS there to reduce the cost. And at the very top of the channel, put in all mineral wool. So you have maybe 4 inches of mineral wool for the top foot, and then you're replacing the inner 3 inches with in the middle of the wall with EPS for portability.
Right. Yeah. You just read my mind. I was just going to say that at the top and the bottom there. Yep.
If I
It-
could chime in there, this is Dietmar with DSA Architects. So we have done on several instances, like rock wool, mineral wool, installations under hardy siding, and it's always much more complicated than you think. Like there's so many details to be worked out, getting the strapping straight, and surprisingly, the industry doesn't even have good solutions as kind of spacers to have kind of a uniform surface so it isn't warpy. The contractors always have to kind of make up stuff in the field. You can detail it as much as you want. It's unbelievable how poorly this is thought through as a system. And I mean, for example, like also in a comment on your graphic here, you're suggesting fire-resistant sheathing for the half-inch that is showing at the bottom. So are you now going through the cost and the chemical imprint of fire retardants for the sheathing through the entire building if it's only needed for the half-inch at the bottom, essentially pushing this into a type 3 construction type expense and complication? And then fire-resistant wood furring, yeah, that's, like on a recent job, the contractor, like especially then if you're going with kind of 1x strapping, like the quality of that, will it crack when you put the fasteners through? They ended up slicing fire-treated plywood into thin strips. So all of this is complicated. I think one solution that I'm looking at, but I haven't really seen that installed much, is stucco straight over mineral wool. Like where you put the stucco netting on top of the mineral wool, the WRB is behind it, and then go straight onto it, because then you have a drainage plane, you have the fire resistance, you have absolutely no airflow going through. And but you don't see that commonly done. Even rock wool on their website, they have some details for so-called one-code systems, but they're all proprietary. They don't fit into the building code. So there's a quick-read detail and some other manufacturers, but it's far from being an accepted solution. I'm wondering if anybody else has experience with stuccoing directly on rock wool.
So Dietmar, I can add to that.
Yeah, Bronwyn, hi.
Hi, how are you?
Good.
I actually researched that about 10 years ago because actually EFIS systems were originally developed with mineral wool as a substrate in Sweden. But because of the leaky condo crisis here in the US, where they blamed EFIS instead of actually blaming poor building science, all the EFIS manufacturers and all the stucco manufacturers have gone to this ridiculous, like, striated drainage plane behind their system, and they won't allow you, or behind the foam. And they also were very reluctant to actually let me put the coating on directly onto the mineral wool. And that was, as I say, 10, 15 years ago now. So maybe that's changed, but it's been a big problem. So I wanted to just quickly go back though, to switch back to the crawl spaces, because there were two questions in the chat. One from Spencer, who was also asking about, like, can we just close off the vents? And I wanted to ask Katy, the detail that I use all across California is I seal my crawl spaces with the Stego, the vapor barrier, and then I do a moisture actuated fan, like a humidity actuated vent fan in the crawl space. And I've been able to get that through permitting everywhere. It's kind of my standard detail, but I don't put the ventilation system going into the crawl space. So it's effectively a sealed, unvented crawl space. And then I also don't do the insulation at the floor and the walls because that gets super complicated. I do it at the foundation footings. So I wanted to just throw that in there as an added option, and hear if you had any thoughts around that.
Yeah, I agree. I mean, we've done that as well. I think we're kind of looking at this through the lens of, if you're doing something new, how would you do it? But yeah, when you're looking at retrofit situations, yeah, agreed, definitely different creative ways to do it. In the interest of time, we probably should move on, but I just wanted to make a couple comments. So yeah, Dietmar, appreciate your notes about things like fire resistant sheathing. That's a big cost. And I think, one where appropriate, intumescent paint, I think can be a great solution, where there's some isolated, material or thing that you want to cover up. And then one other, just quick comment on John, you're kind of offering of, can you do two different layers? I think, anything's possible. We're not ourselves experts in like, what are all the different variations of like fire rated assemblies, and what's the difference between like a fire rated assembly versus something that hasn't been tested, but that really works. So we're kind of looking at this more through the lens of like what works. But from a cost standpoint, I think it's like every time we're on the building just adds a lot of cost and complexity. So I mean, I'd be a little hesitant of like two different layers of something when maybe there could be a simpler way. And then you can get into maybe where does dense glass kind of play a role when you really need a robust assembly. So anyway, but yeah, we should jump. And Nate, we're gonna go back to Nate, but I'll just briefly comment here. Yeah, this was a house in Telluride that didn't necessarily go in with a lot of fire resiliency features in mind, but we just have a couple pictures here just to show the detailing of furring over mineral wool. So this uses system sheathing for a great airtight kind of foundation, and then furring strips. And then Nate, back to you. We might want to kind of motor and kind of just get to the HVAC stuff, but I don't think we have much left before just a slide or two on some mechanical considerations.
Yeah, I'll go quickly. And I mean, I don't want to I'm sure you're all well aware of the benefits of outsolation, right? You eliminate it, it's a pretty significant penalty. So it's quite the advantage to include it, and it adds some long-term durability improvements, with kind of the main one being it keeps that sheathing layer warm, and the colder the climate you're in, the better that warmer sheathing is for performance. And of course, when you're adding that exterior rigid insulation, it does add some kind of complexities and additional detailing around where you're going to locate your windows, where you're going to locate your WRB, and then how to attach your cladding. So we can go to the next slide. And on that note, RDH has a great presentation and a document on attaching cladding over exterior rigid insulation, and it looks at all sort of your lightweights all the way up to your lightweight, just wood or fiber cement siding, all the way up to your stone and brick veneer and whatnot. And then if you go back.
And then just a quick one I wanted to call out. So Dietmar, you mentioned the challenge of mineral wool, which, no arguments there. If you haven't checked it out, that Helix, the Heco Topics Therm screw is pretty interesting. If you have used it and it didn't work for you, I'd love to learn more about it. But, this can be, I think, a really good solution to help with mineral wool applications.
And also on furring, I've had personal experience trying to install furring strips over thick layers of exterior rigid. And one thing I found was I just had to pre-drill the top and the bottom holes for the screws, and that pretty much eliminated any splitting. And just anecdotally, sample size of one, but it really seemed to help. So we can. If you keep clicking, it's an animation again. So we prefer to avoid foam plastics. Again, there's a trade-off with costs and whatnot, but the plastic insulations just for environmental and health benefits and whatnot. And then when we're getting into fire safety, they do have flame retardants in them, but are they good enough for wildfire situations? Is it adequate enough is an open question. So we do like to work with the more natural insulations like cork, wood fiberboard, and mineral wool. And those are in the descending order of cost typically. And we just want to quickly highlight that there is now a domestic manufacturer of wood fiberboard insulation. So we're hoping that drastically reduces the cost since it doesn't have to be imported from overseas. We can move on.
And Brown would just mention headboard is now also available. So yeah.
When it comes to windows, I guess the key detail here is just to make sure at least one of the panes is tempered. These are designed with much higher heat resistance, less likely to break. And again, it's that radiant heat is a big factor in the breakage, as well as I know we're not getting too far into it, but that buffer zone around the house, making sure you don't have flames, flammable material right against the house that basically overheats the glass and causes it to break. It's best to have both panes tempered just for redundancy, as a common failure mechanism is if they do get too hot, that whole pane will just fall out of the frame. So you still have the inner layer as a backup to some extent, but there are certainly cost implications. And if you have to do only one, then the interior is the recommended choice. And if you want to go belt and suspenders, I guess you can add in roll down fire doors or metal shutters that are either manually closed, or you can have them activated with a fusible link. That's basically, once it gets hot enough, it triggers a switch in or releases a spring, and that metal door will close over the windows. So ventilation requirements, continuous whole house ventilation, it's required by code. How much you need, it's basically 3% of your floor area times 7 or plus 7.5 times the number of bedrooms plus 1. In numbers, that just means a 1,500 square foot house with 3 bedrooms, you need to provide 75 continuous CFM, or 3,500 square foot house with 5 bedrooms would require 150 CFM. Locally, you're required to provide at least 20 CFM in a bath, or 50 CFM intermittently. And a kitchen with an electric range is looking at about 110 CFM for a home over 1,000 square feet. We'll get into ways to provide that ventilation, but for air quality during wildfires, the best approach is whole house central ERV or HRV with a MERV 13 filter. And then it's a good idea to use these in lieu of individual bath fans. So you can basically provide a boost switch in your bathroom to ramp up the ERV or HRV to get higher flow rates instead of installing a separate bath fan. And what that does is that routes all the bath exhaust through the ERV and out one hole in the house instead of a separate hole for each bath fan. And then kitchen range hoods always vent to the exterior, and that certainly can't be routed through an ERV or anything of the sort, just standalone exhaust fan. Next slide. So providing whole house ventilation, you can do exhaust only, which means basically you have your bath fan running continuously. Air is going to exhaust out of that, and then makeup air is basically pulled in through the natural leaks in the building. Supply only, that gives you the added benefit of controlling where the air is coming from and gives you the opportunity to filter it as well. Whereas with the continuous bath fan, you have no control over where the fresh air is coming, and no idea what the air quality impacts of that is. You can integrate it with your heating and cooling system, but we really, unless there's some compelling reason or design constraint, we really push an individually ducted system, just because the balancing of the system with the HVAC with your heating and cooling system being intermittent, it just complicates the installation, and it's not quite, in practice, it's difficult to get right. On paper, we can generally make it work, but by far the best way is an independently ducted ventilation system or operated ventilation system. We can go to the next slide. Yeah, so you can use a heat recovery or energy recovery ventilator. The main difference is heat recovery, it's sensible heat, so that's the temperature you feel, whereas the energy recovery is going to recover moisture as well. So it basically transfers some humidity between the incoming and exhaust air supplies. Importantly, they do not mix. It runs through a different type of heat exchanger depending on whether it's an HRV or an ERV. These systems are balanced, so you're not creating an imbalance within the house, say from, as you would with a supply only, where you'd be pressurizing the house, or an exhaust only system where you would be inducing a negative pressure within the house. During wildfires, you can either reduce the airflows or just turn off the system depending on the severity. But again, with the MERV 13 filters, those do a pretty good job filtering out the wildfire smoke and particulates. So it's usually not advisable to turn them completely off.
Is
And
there
again, the duct.
is there
Oh, yep.
a preferred strategy for makeup air for a separate range hood?
For that gets into if you're pushing, like we like to push an all electric house. So one of the main concerns with the makeup air without having makeup air for kitchen exhaust is backdrafting any of your combustion appliances, any natural gas combustion appliances, and particularly those that are naturally drafted or atmospherically drafted, and less of a concern with sealed combustion systems. But in passive house levels, when you're getting down to your 0.6 ACH 50 or equivalent on your envelope leakage area, the challenge there is your fan may not be able to hit its rated capacity just due to how tight the building is and inability to kind of pull in that makeup air. So there are a few options. You can do an interlocked motorized damper that just opens up a duct depending on the CFM of your range hood. It's size based on that. And it's interlocked, so it'll open up that damper whenever the range hood is operating. There's also gravity damper type systems as well that are just completely passive. And once it detects that negative pressure, the damper, it effectively opens that damper and allows makeup air to come in.
Yeah, and one quick note on kind of wildfires there is like we've had clients ask for, filtered makeup air. These systems, they sound really simple. Like how hard can it be to just provide makeup air for the, 300 CFM range hood? But it's a lot of air, and to provide it through a duct, like these ducts end up getting really big, and when you're trying to put filters in, it can kind of get crazy. So, all things being equal, at minimum, I think a best practice is always to minimize the size of the range hood to start and actually install it properly. So like how many pictures have you seen in Dwell magazine where like the range hood is 10 foot above the cooktop? I mean, it just doesn't, it's not per, manufacturer specs. So trying to do like a right sized hood over an induction cooktop and, have it be 150 CFM, it makes life a lot, just a lot easier. But if you can avoid makeup air and just crack a window, not that you want to do that during wildfires, but if air quality is really bad, maybe there are bigger issues to work with. So anyway, just a thought on that. And I'll let Nick get back to it. I think we have one more key slide, and then for anyone that does want to stick around for some more Q&A, we can, but I realize we're already 10 minutes over.
Yeah. So going quickly again. So like your Vulcan vents, those they're not necessarily appropriate for mechanical ventilation systems just because they include an 1/8-inch mesh on them, and though that's basically a filter in itself. So with those mechanically vented systems, it's likely those are gonna that 1/8-inch screen is gonna clog frequently and require frequent cleaning. So there's certainly some maintenance concerns and trade-offs there, and I think it's going to be something that would be irregularly maintained and lead to issues. So As an alternative, you can install a butterfly damper on your intake, well, on your exhaust, and those will just open whenever the system is running, and then they close when the system is off. On the fresh air supply side, though, the damper application is not as straightforward because you want the damper to open in and allow air to come into the building. So a few options there. Well, I guess the main option is using a motorized damper of some sort that's either interlocked with the system or on its own switch that you just flip off. You switch whenever there's a wildfire nearby to basically prevent embers from entering into the system. And then the other important aspect is using metal ducting at least a few feet into the building, but ideally all the way into the appliance itself. So any embers that do find its way in, they don't have, there's no combustible material nearby. Or if you have flex duct, for example, it doesn't just melt through and start providing a pathway into the building. Again, we mentioned combining your bath exhaust with the HRV and ERV to reduce penetrations. I've shown a boost switch there on the bottom center, and you have the opportunity. There's options for humidistat controlled, so it just automatically kicks on in the bathroom whenever the humidity rises. And then you also have the timer control where you can give it 1, 2, or 3 taps for 20, 40, or 60 minutes of boost operation to promote eliminating that water vapor or odors. Yeah.
This was fabulous. I wanted to just throw this question in here too. Is there an advantage to using slight positive pressure in wildfire situations to prevent infiltration in unwanted areas? Thought that was an interesting question for you to wrap it up. I don't know how we would test that.
Yeah, I can jump on that briefly. I mean, I think there's some benefits in just for normal operation of slightly positive pressure, because then, you know, with a standard MERV 13 on supply air, you know, you're truly filtering the air coming in. But in terms of like a fire resiliency strategy, my instinct is it probably really doesn't matter at all, because we might be talking about a slight pressure difference. But like that example Jay gave, you know, if wildfire's like, you know, coming to your neighborhood, the winds are so high, like a 10 CFM pressure, or, you know, whatever, a minor pressure difference in the home, I think it's going to get diluted pretty quickly by the pressures, you know, that are that come from just the wildfire coming through. But I mean, great question, but that's kind of my instinct on, I'm not sure. And Cyril, if you could just go one more, then we're kind of on the.
Can I ask a question? There are zillions of homes that have vented attics, and there are wildfires that can occur anywhere. The state fire marshal has 4 kinds of approved vents. And my question is, if you install state fire marshal approved vents correctly, and there's a wildfire, what is the experience of the firemen in the Palisades fire in those situations?
I mean the crawl space and the soffit ventilation for like
I'm talking about attic.
Yeah, attic. I mean, at least on paper, it's probably going to improve the attic area, that infiltration into the attic. If you say use the Vulcan vents for your soffit vents and whatnot, that's going to limit the embers from entering the attic. But my concern is, what about the rest of the air leaks in those existing buildings? So it may reduce the risk up in the attic, but I don't know if it's going to help so much in the other common air leakage areas.
Yeah,
So-
and I know, like, we don't have stats on kind of all the documentation of every fire that happened and kind of what led to it.
Oh yeah, no, it just
And I guess another factor that comes into play is we didn't get into it, but the combustible zones, there's like a 0 to 5 foot, like just no combustibles against the building. And then is it 5 to 30 feet? There's some limitations, and then 30 feet out, there's kind of those factors you have to consider as well for how it's going to impact the survivability of a home. So again, I think it'll reduce the risk to the attic, but the overall risk is just influenced by so many other factors that it's tough to say whether that alone would have improved the survivability of the homes.
Thank you.
All right. Well, thank you so much. There are emails on the screen. You can reach Katy and Nate at Beyond Efficiency. If you have any other questions and you don't have a chance to write down their emails, you can contact any of us at the Passive House Network or Passive House California. But we do need to wrap up, and this has been wonderful. So much great information. Thank you so much. If you have additional questions,
And-
please reach out to Katy and Nate.